Good afternoon, pre-calculus students. Today we're doing Notes 1.2a functions. Don't forget your name. I want to tell you a story. So I had three friends in high school, and one of them were a couple. They're doing really good. And then all of a sudden, the couple decided to break up. Well, they were all three friends, but the girl decided that she was going to date her ex's best friend. What do you think happened to the relationship with the two guys that both had dated the same girl? Unfortunately, the relationship didn't function because they shared each other's ex. We can't share exes for relationships to function. Now, disclaimer, I think that you can make peace in any situation given God's grace. But for this example, I want you to understand that in math, a function is from a set to a set is a relation that assigns each element x to exactly one element in the set y. The set of the domain is the set of inputs, f, and the set of the range is the set of outputs. So a function means that we do not share our x's. For a relationship to function, we don't share our x's. So that means like if we have some points 3, 5, 2, 4, but then if we have 3, 6, do you see here how 3 dated 5 and 6? This relationship cannot function. It can't work, unfortunately. However, we can have relationships function where y's are shared. You don't really care if your friend is a player. If we have these guys here. So 5 dates 3, 2, 4, 1. That's okay, as long as he doesn't date our ex. If we have another guy over here that's got an x of 6, then that's okay because they're not dating each other's x's. So what we're going to look at today is it's only when the x's are shared, if an x value is repeated and has different y values. So looking at here, our inputs, our domains, our x values, 2, 2, 3, 4, 5. Well, we see that we have two x's here, and they're going to different y's. 11 and 10 cannot be friends because they shared 2. There's not one input for every output. What about this function? We're looking here. Every x has its own y. It's okay that we have some there. There's no shared x's, so this is good. So this is not a function, and this is a function. Okay, going down here, we see that we are looking at determining whether each represents a function of x. This one doesn't give us the set of points, and it doesn't give us the graph. But we can determine, by solving for y, how many y values we would get if we plug in x. If we plug in x, how many y's do we get is the point. Because if we plug in x and we can get multiple y's, then that means that our x's are being shared. So in this case, if we plug in a value for x, we're only going to get one answer out of here. So this is a function. Y, there's only one choice coming out of y. Y equals whatever you plug in. However, let's solve for this y. Add x to the other side. Y squared equals x plus 1. Now, if I solve for y, I have to take the square root, which tells me I'm going to have a plus or a minus. How many answers do I have coming out of this y? I have 2 x's. So I have 2 x's coming here. And so that's going to pose a problem for us. The plus or minus shows us that we have, for any given value of x, it corresponds to 2 values of y. When we plug an x in, we're going to get 2 answers for y here. So for instance, like if we have that x equals 3, if I plug 3 in, I'm going to get plus or minus square root 4. Y, so for x equals 3, I'm going to get a positive 2 and a negative 2. That can't function. We're sharing our relationships. So this one is not a function because there are 2 outputs for the one input, 2 y's for the one x. Okay, last thing, we're just reminding ourselves of function notation. Function notation, we're just looking at, okay, g of 2, this means that our function notation is typically g of x or f of x, whatever value is there. So this is our value for x that we are plugging in to our equation here. So negative 2 squared plus 4 times 2 plus 1. That's all we're doing there. Negative 2 squared is negative 4, plus 4 times 2 is 8, plus 1. Negative 4 plus 8 is 4, plus 1 equals 5. That's our value for g of 2 there. We're literally just replacing it. Okay, what about here? G of t. We're literally plugging in t for x up here. Negative t squared plus 4 times t plus 1. And that's about as far as we can go. We can simplify it from the parentheses. But after that, that's our function g of t. And I could have written this one as g of 2. All right, last, g of x plus 2. For this one, we're going to replace x plus 2 in for our x's up there. Negative x plus 2 squared plus 4 times x plus 2 plus 1. And for this, we're going to have to FOIL, and we're going to have to distribute. So if we distribute 4x plus 8, and then this one, we could rewrite this as x plus 2, and then we can FOIL it. So I get x squared first, outside, inside, last, plus 4x plus 8 plus 1. And then this negative is going to distribute to everything here. So I get negative x squared. I could combine these two to get 4x. I would get negative 4x, negative 4, plus 4x, plus 8, plus 1. Okay, I have negative 4x plus 4x. Those cancel out. So I get negative x squared. I combine these guys. Negative 4 plus 8 is 4, plus 1 is 5. And I get negative x squared plus 5. So g of x plus 2 equals negative x plus 5, squared plus 5. And that's your notes on functions.